triangle is a three-sided figure, three straight sides, right? It makes a triangle. You learned that in kindergarten, probably. So here's a triangle, a ramp, like a water skiing ramp, or a snowboarding ramp, or skateboarding, okay? And it has three angles in this triangle. Which type of angle is not in this triangle? Read. There's no obtuse angle in this triangle, okay? This angle is right because it has a little square. That's how you designate a right angle. And these two angles are less than 90 degrees. That's what an acute angle is, less than 90 degrees. An obtuse angle is greater than 90 degrees, and there aren't any in this triangle, okay? Let's measure this unknown angle. How do you measure an angle? What tool do you use to measure an angle? Blake, a protractor, okay? Now, we're not going to use a protractor. I'm not going to give them to you because of COVID, all right? You've already learned how to use protractors in a previous grade. Not that that means you know how to do it still. Okay, so let's just review quickly how to measure an angle with a protractor. Here is my protractor. Okay, so you take your protractor to measure the angle and you do what with it? Go ahead, Reed.
You put the center on the end of the angle.
Yeah, what's the end of the angle? What's the official math term for that? The point of an angle? Starts with a V. The vertex. Multiple is vertices, right? But the vertex. Okay, so you put the center on the vertex of the angle that you want to measure. Okay, so I put the center on the vertex of the angle that I want to measure right there. And then what do I have to do? Wait. Put the zero on the line that you're going to start with in the angle. So the zero line right here, I put on this zero, and now I can read the number of degrees of this angle. What is the measurement of this angle? 170 degrees, he says. This little angle here is 170 degrees? No, what angle is 170 degrees? Well, this angle is 10 degrees, okay? This is 10 degrees. Oops, I can't. Nope. This angle right here is 10 degrees. This angle is 170 degrees, okay? The protractor has two scales on it, right? It depends on where your zero is. If your zero line is here, then you're on this outside scale, and the answer is 10 degrees. If your zero line was this one over here, then you would use the inside scale, and this angle would be 170 degrees. That's why there's two scales on the protractor, okay? You do not have to do any protractor work this year. It is not a 7th grade topic, okay? It's a 4th grade topic or 5th grade topic, so you learned it then, and now you're supposed to know how to still do it. So the answer is 10 degrees. Okay. What is the relationship between this angle and this 80-degree angle? What is the relationship between this angle, unknown angle, and this 80-degree angle? What are they? What is the relationship of those two angles? They are what? Read.
Acute.
They're both acute, but the two of them together, one is 10 and one is 80.
90.
They add up to 90, so they are,
Right.
the pair of them are complementary. What we just did for the whole first half of class.
Wow.
Complementary. Two angles that add up to 90 degrees. Draw a triangle with an obtuse angle in it. In this box right here. Draw a triangle with an obtuse angle. Very nice, Reed. draw a triangle that has an obtuse angle in it. Obtuse angles are bigger than 90 degrees, right? Wide angles. Keep going. Oops, not quite. Right, which of these would be obtuse? Which one of these angles is more than 90? If you draw this line out here further, then this angle would be. All right, so some people have angles that look like this. Okay, some people might draw one that looks like this. Okay, either way, okay, this angle here or this angle here is obtuse, greater than 90 degrees. Okay? What are the other two angles in these triangles? One is obtuse. What are the other two angles, Blake? Acute. Okay? Can I draw a triangle with more than one obtuse angle in it? No, I can't. Because if I have one angle that's bigger than 90 degrees and I draw in another one, well, these aren't going to connect. I can't make it out of shape with three sides. Okay, I can connect it and make it a quadrilateral, but that has four sides. Okay, same thing with a right angle. If I have one right angle, can I have another right angle in this triangle? No, because a second right angle would not connect. I'd have to put a fourth side on it, and it's not a triangle anymore. Okay? So a triangle always has two acute angles. Every triangle has two acute angles. The third one is either acute or obtuse or right. And that's how we classify or name triangles. This website is really good. I'm not sure what's going on. Math is fun. Very good lessons on stuff. Okay? If you're having trouble remembering what's happening in class, go to that website and just search on triangles. Okay, so naming triangles. Triangles are named in two different ways. One of them is for the angles. Okay, and so if all of the angles of the triangle are acute, three acute angles, it's an acute triangle. If it has one right angle in it, it is a right triangle. The other two are always going to be acute. If it has an obtuse angle in it, then it is an obtuse triangle. Okay, so three types of triangles by angle: acute, right, or obtuse. You can also classify triangles by the lengths of the sides. This triangle has no sides the same length. None of them are marked with little tick marks, which is how you indicate that lines are the same length. You might see a picture like this that has three different sets of tick marks to show that they are three different lengths. Three different lengths is a scalene triangle. Scalene. If two of the sides of the triangle are equal, shown here by having the same number of tick marks, that is an isosceles triangle. An isosceles triangle. If you don't have your book, you're probably going to want to write these 6 things down so that you can do the problem. Okay, if you have your book, you can go back to page 556 for these different classifications of triangles. Finally, if all three sides of the triangle are the same size, the same length, that is known as an equilateral triangle. Equi meaning equal, and lateral means sides. Okay? Equilateral triangle, all three sides are the same length. I will tell you also that if the sides are all the same length, all of the angles are equal. If two of the sides are the same length, then two of the angles are going to be equal. We'll talk about the angles here in a minute. And if the three sides are all different, then all three angles are going to be different measurements also. Okay, so classify the triangle. So this says draw a triangle with an obtuse angle and no congruent sides, and then classify it. So you, one obtuse angle, you connect it to make the triangle. You can show that the three sides are all different lengths by giving them different numbers of tick marks. And this is an obtuse scalene triangle. Obtuse because it has an obtuse angle. Scalene because the three sides are different lengths. Now you are tasked to draw a triangle with a right angle and two congruent sides. So it should look something like this, right? Pretty much that's your only choice. Some people may draw it like this. You have to show the right angle with the little square. That's how you show it's a right angle. And that the two sides are the same length by tick marks. This side across from it cannot be the same length as these. It's impossible. Okay, so you can't have a single tick mark on this line. What is this triangle? What is the classification of this triangle? Jordan.
A right triangle or isosceles.
Right and isosceles, not or, it's both. It is a right isosceles triangle. Isosceles because it has two sides the same length. Okay? Then they give you these real world pictures, okay? So classify a triangle in a real world picture. Two sides the same and an obtuse angle means an obtuse isosceles. This one, it looks like the three sides of this are different lengths. And it has a right angle in it. So this triangle is right and not acute. Can't be right and acute. Nope. That's for the angles. The angle is either acute, right, or obtuse. This one is right. Scalene is the next part. The lengths of the sides are all different. Scalene. Okay. Now, is it easy to remember these words? Scalene, isosceles, equilateral, right, acute, obtuse? Probably not easy. That's why you have to have notes or look at the notes when you are practicing, because you have to know what those 6 words are, what they mean. That's what you're supposed to be learning here. So when we do the practice problems, which is a bunch of IXL stuff and another pizzazz worksheet, if you don't know what isosceles means or scalene, have the notes in front of you. So that when you do the practice problems, that's how you remember and learn what those words mean. All right, the last part of this is a special rule about the angles of triangles. The angles of a triangle all add up to 180 degrees. Always, for every triangle. The 3 angles in a triangle always add up to 180 degrees. 1, 2, 3 angles. Okay? So, if you know 2 of the angles in the triangle, you can always find the 3rd angle. The book does this with a long algebra equation. Okay, this is the algebra way to find this answer. You do not have to do this. Okay, not required. Instead, my method for doing this is add up the 2 angles that you know. 49 plus 119 is 162. That means this 3rd angle has to be 180 minus 162, or 18 degrees. You know 2 of the angles of the triangle. You add them up. You subtract that from 180 to get the 3rd angle. So, triangle ABC, if angle, and you can draw this out if you want. Angle B is 108. Angle A is 25. And what is angle C? What am I going to do to find the measure of angle C? Okay, Reed, go ahead.
Add 25 and 180, and then subtract that by 180.
Add 25 and 108, and you get 133. The three of them together add up to 180, which means that the third angle is 180 minus 133, or 47 degrees. Okay? So the three angles of a triangle always add up to 180. Go ahead and, now, there's another question here with this picture. I'm going to skip that one. Go to the guided practice here on page 558. Okay? So your triangle here should look something like that. Two sides have to have the same number of tick marks on them. And this is an acute isosceles triangle. Three acute angles and two sides the same length. What is the measure of the missing angle in this triangle? Triangle RST. Angle R is 37, angle S is 55. The missing angle is, Jack, 88 degrees. Add these two together, and then the third one is 180 minus that. And finally, this rack, the missing angle of the rack is 60 degrees. In an equilateral triangle, the angles are always 60 degrees, because all the angles have to be equal also. Clear. So classify the triangle. So you look at triangle 1, and you say, why are you packing up? We have 5 minutes left in class.
I thought everybody's taking out the clothes to get one.
That's possible, but I don't think that's necessary right now. Okay, so take this triangle, 9 centimeters and 9 centimeters. Those are the same length. It's three acute angles. So this triangle is acute isosceles, number 1. So over here you find acute isosceles and you put in a number 1 next to it. Okay, one of these will not be used. There's 7 answers and there's only 6 triangles. Okay, in the bottom part of this, in the box, write the missing measurement, add up the 2 that you have, and subtract that from 180, and that's the number that goes in here. Okay, I'm not worried about the riddles being done. You don't have to do the riddles, but do the arithmetic, do the math problem.